All right, here we go. Remember what we're trying to do. And you have your little reference sheet, so you can use that. We're trying to simplify one side into the other. So let's take a look and see if we have any ideas about how we might do that for problem number 5.
Can we do anything to the right side?
What?
We can't change the right side.
Now, I shouldn't say it. You can only change one side. So if you think it would be easier to change the right side, then you can change the right side but not the left. So I'll look at the problem and give you my expert opinion here. I think definitely we want to change the left side.
Sine squared over the cosine.
And the reason we want to change the left side is because the building blocks of trigonometry are sine and cosine. Everything can be boiled down to sines and cosines. So I'm going to leave the right side at B and mess around on the left side. Now, let me give you another hint based on, almost half a century of teaching this stuff. Isn't that crazy?
You know you should make it half a century.
No way. Okay. I want to end up with all cosines. What function is the reciprocal of cosine?
1 minus.
One number 5.
1 minus 5?
No, secant.
Oh.
So here's what I want you to think about. If you have secants, can you automatically change secants into cosines? Yes, because secant is 1 over cosine. So that's an easy switch. So I think I'm going to take that tangent squared in the numerator. Now, you can do that, but again, I'm focusing on this idea of secants. So I'm going to take that tangent squared, and remembering that 1 plus tangent squared is secant squared. Line number 5, page 51.
There we go.
So knowing that 1 plus tangent squared is secant squared, can I change my tangent squared into secant squared minus 1? And again, there is nothing wrong with going sine squared plus cosine squared, or sine squared over cosine squared. I'm trying to get everything in cosines, and so I'm aiming for secants. Because secants I can change to cosine. Now, these do not cancel. Please don't cancel anything. What do you notice, though, about secant squared minus 1?
You can spoil it out or whatever.
Secant squared minus 1 is the difference of squares. So it will factor into secant plus 1, secant minus 1. And then what will happen?
You can cancel.
Now I can cancel. So now I'm left with secant minus 1. What is secant? 1 over cosine. You're almost there. You have basically one more step, Ronan.
Where'd you get the minus 1 from for the top sequence?
For what now?
Because tan squared x is equivalent to secant.
Tangent squared is secant squared minus 1.
Yeah.
Ronan, tan squared is secant squared minus 1.
Oh, right. Should I add that to my reference sheet?
You can write anything you want on that sheet. Now remember, on test day, I'll give you a different sheet.
So we're supposed to memorize that?
No, you'll have, this is on the sheet.
Okay.
You'll have that.
Oh, I asked you guys.
Yeah, you'll have that. But all of the different, like, it doesn't say on the sheet that tangent squared is secant squared minus 1. You're supposed to be able to figure that out. All right, what do I do? Here I am, guys. I'm almost done. One more step.
set it equal to,
Get a common denominator. So you have 1 over cosine minus cosine over cosine? And what's that?
1 minus cosine.
1 minus cosine over cosine.
Wait, so this problem was pretty much like proving.
Yes, that's exactly what we're doing. We're proving that the left side equals the right side. And every problem is going to be different. But think about what are some of the things we thought about and did in this problem. Well, first of all, we used one of the identities on the paper, but we used it in a different form. Then we factored the difference of squares, we canceled, we got common denominator. Little tools that you have. Right, before I erase it. Okay,
If we can't prove something in those solutions.
it is, but I will never purposefully give you one that doesn't verify. Okay, we do that with some of, like in honors, we'll do that, where they don't know, and then they spend all this time, I won't do that to you. If I give you a problem and tell you to prove it, it's going to be provable, all right? What you want to do always is get as far as you can. If you can't make it to the end, okay. But don't erase everything and leave it blank. Leave everything there and leave it blank. All right, here we go. What do you think when you look at this problem?
what's that?
I said, what do you think when you look at this problem?
You want to end up with the coast on top, the side and bottom.
Yes, that's exactly right.
How do you make it?
I want-
This is the easiest thing to do.
Jake,
Why would it cosine be on the bottom?
Jake, Jake, stop.
Something, oh.
Jake, this is my end point right here. This is what I'm trying to prove. What's on top?
I cosine.
What's on the bottom? That is what I want to get. Now, how I make that happen, I don't
Figure
know,
that out.
but that is what I want to end up with. Okay? All right. Now, when you look at the problem, you got to get a common denominator. These two are fractions and they're being added. So you got to have a common denominator. So the common denominator, this one will need a sign, number top and bottom. This one will need a 1 minus cosine. All right? Now, I know this is hard. I know you've never done it before other than the other day. But you should be able to recognize, oh, I'm adding fractions. I need a common denominator. All right? That's not a stretch. So what is my denominator then? Sine and 1 minus cosine. I'm just going to leave it like that. That's my common denominator. All right, so what have I got up here? I have sine squared plus, now this is a FOIL, right?
Yes.
So that's going to be plus 1 plus cosine. No, that's a minus right there, isn't it?
Yeah.
Okay. So it's going to be plus cosine minus cosine
Cosine squared.
minus cosine squared.
So minus 9.
Would everyone agree with that?
Yes.
Okay. So did you notice these cancel?
So for negative. Yep.
I'm trying to think which would be the best way to do this. What's this right here?
Negative cos squared t plus 1.
What's 1 minus cosine squared?
Squared.
Tan squared.
No, look your
Sin.
sheet.
Oh, sine
So
squared.
sine squared plus cosine squared is 1.
Yes.
So if you have 1 minus cosine squared,
That
which is
equals
what I
sine
have up here,
squared.
that equals sine squared. Would you agree with me?
Yeah.
So what, this makes sine squared.
Yes.
So what do I have on the top?
2 sine
2
squared.
sine squared, which is really good news because I needed 2.
Yeah.
And now I have it. So now I have my 2. Also, I can cancel one of my sines. Would you agree with that?
Yeah.
We can.
Because this is factored out. This is a multiplication
Oh,
here.
okay.
So I'm gonna have 2 sine on top of 1 minus cosine.
You have to move that cosine to the top.
So
Wait.
let's make sure we're all where we are. That's where we wanna be. We're not there yet, but we're getting there. We okay to here?
Yeah.
Now, this was the last thing we talked about. We went to watch wrestling, walk through the halls, and then we came back and we talked about it again. This is where I am. This is where I want to be. Okay?
You just like add, not add, but multiply, make it the same thing.
Yeah, so what do you want to multiply by? Has to be the same thing in the top of the bottom, so I would suggest we either put a sign in, so that I got a sign in the bottom. This, by the way, is gonna bring me right back to where I was here. Or
Multiply by 1 minus cos.
multiply top and bottom by 1 plus cos, that's what I want, yeah. So, let's do that this time. Let's multiply the top and the bottom by 1 plus cos. Now, you guys, you're allowed to multiply by whatever you want, as long as you do it to the top and the bottom. This is where I want to be. At this moment in time, when I was here, I didn't have a cosine, so I'm sticking it in. That's what I want. So now I'm going to have 2 sine, 1 plus cosine. And what am I gonna have in the bottom?
Cosine 1.
What is this when you FOIL it? FOIL that out.
Negative cosine squared. Plus 1.
FOIL. Don't we get 1
Plus
minus
cosine squared.
cosine squared,
Yeah. Which equals sine squared.
which equals sine squared? Anything good happen there?
You can't sine this out.
One of the signs will cancel.
So then just there.
And voila. Isn't that what we wanted?
Yeah.
How did the signs cancel? Or, oh, never mind.
Yeah, square.
Yeah.
Okay, is it a lot? Yeah. It is. We just have to practice.
This forward.
And luckily, I have a sheet with a few more practice problems on it.
So on the top right, how do you do that like arithmetic to go from like that FOIL problem to 2 sine squared b over sine? So on the bottom left, how'd you get that from?
These cancel. 1 minus cosine squared to sine squared. Yeah. So that's a sine squared and that's a sine squared.
Oh, okay.
So that's 2 sine squared. All right. I put together some practice here. We're gonna do. We've got more in this chapter than just this stuff. So we could spend, oh goodness. We could spend forever on these. I love doing them, you love doing them. But, we gotta move on a little bit. So we'll pick a practice problem for this sheet right now. And I'll try to remember, you remind me, we might do one every day and then we'll practice every day. Okay. So did everybody get a practice? Okay. So we're gonna do one right now, so look at the page. That front page, it says verify the following. There's a back side too, but we're gonna stick just with the front side for now. Do you see one that you think, oh my gosh, it's crazy?
Two.
Number
It's a
two?
good order, it's pretty good.
All right, we can do number two. All right, so we're on the extra practice I just handed out. The objective is that you are going to be able to at least start one of these on your own. Okay?
Did you see we have another test before the quarter?
Yeah.
Okay, good.
So, I test over 5-1 to 5-4. We're gonna start 5-3 here in a minute. But somebody suggested problem 2, so I am doing it. Okay? Yeah, you'll wanna do this on another sheet of paper, you guys. There's no way you're gonna squeeze it in here, so just on another sheet of paper. Oh, we forgot to do a review problem 2. We'll do that when I'm done. All right, take a look at it. This is problem number 2 on the review packet I just handed out. Does anyone notice anything?
No, they're all square.
Well, we've not encountered this before. We've got 2 different
They're
variables
all
involved.
different, they're all different, things.
So that when you, if you're gonna use anything on your reference sheet, the variables have to match, okay? So you can't combine a sine squared A and a tangent squared B. They don't combine. But these 2 could be combined, and in fact, what do they combine into? 1. So now I have, these make 1, so now I have 1 plus tangent squared. Bing, 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 look at your sheet. What is 1 plus tangent squared?
Secant squared.
Done. Isn't that what we were trying to end up with, guys? Okay, that one was too easy. Let's pick one more. Pick one more. Pick another one from the front side.
12.
12. 12.
Oh, so I'm supposed to put 1, and then, oh, right. That's maybe.
Okay, we want that to be. Now, when you are doing these, I can't remember if I said this the other day. If you are uncomfortable with the thetas, you can change those to x's or something else if you want to. It doesn't matter. It's just a variable. It doesn't matter.
Right.
Now, when I look at this problem, the first thing that occurs to me is that everything on this side is a tangent, except for that. Could I change that into a tangent easily? 1 over tangent. And then everything over here would be tangents, and that's what I want to end up with. Okay, so that's something that occurs to me. Remember, you have to do something. So, if you notice, hey, I gotta end up with a tangent, I can easily make this a tangent. See what happens when I do that. So I have 1 minus tangent squared over 1 over tangent squared minus 1. Now, this is called a complex fraction. It is a big fraction with a littler fraction inside of it. The easiest way, and you can do this other ways, I don't want to infringe on what you already do or know how to do or are comfortable with, but the easiest way is to look at the 4 parts of the problem and say, okay, what's the common denominator of the 4 individual pieces, tan squared. So I'm gonna multiply this by tan squared, this by tan squared, this by tan squared, and this by tan squared. Now, what is the benefit of doing that? Won't that be gone? You're never gonna get rid of the big fraction, but I can get rid of the little fraction by multiplying everything by tan squared. So now I have tan squared minus tan to the 4th over 1 minus tan squared, this leaves me with 1, minus tan squared. I can't cancel till we factor.
Secant squared.
You gotta factor first.
Oh, one's tan.
Difference in squares on the bottom.
Or you have to do different squares.
Okay, let's hang on a minute. What can I do to the top?
Take out a tan square.
Take out a tan squared. And Joe Garvey, when I take out a tan squared from the top,
You get 1
what am I
minus tan
gonna
squared.
Ah.
Oh my god.
And what is so awesome about that?
It's sequence, you go sequence.
It's my denominator.
Oh.
Now, 1 plus tangent squared is secant squared, but I would not do that in this problem, because remember, I want tangents. I want tangents.
I know that. Well,
That's what I wanted to end up with, so I don't want to be changing into something else. I want to do the problem in tangents. Okay? So, up to this moment, I get my reference sheet away. Up to this moment, we have focused on, we've used this one, sine over cosine tangent, and we've used these 3 a lot. The Pythagorean identities, sine squared plus cosine squared is 1, that little blue thing. Today, we're gonna move into using some more on the sheet.
No.
All right? So, let's look,
the more I see.
we're going back to our notes now.
The more the rest.
Review problem. This is a review problem. Then we're gonna get started on our notes. So, tangent 3 pi over 4. First thing you might think about is that's 3 1/80s divided by 4, which is 135.
Yeah.
And then you're thinking about, okay, 135 is right here. Here's 135. So this angle is 45,
1.
1 root 2.
Oh, there's a -1.
Negative right there. So the tangent is opposite over adjacent y over x.
Yeah.
That would be -1. Hmm?
I know, I see that.
Yeah, that's a review problem, but in a minute, you're gonna see why it's crucial that you can do that kind of thing. Are we good with that? All right. Number 1 says find the exact sine of 15. Now, here's the scoop, kids. The only angles that you can do like this that we just did are some version of 30, 45, or 60, right? That's it. So what in the heck am I going to do with 15? I'm going to rewrite it as the difference of 2 of those angles that I do know. So so do you think, remember, you're working with 30s, 45s, and 60s. Could you rewrite 15 as a combination of those two?
Which is 5, 2,
45 minus 30? Isn't 15 45 minus 30? So I'm gonna think of this as the sine of 45 minus 30. This is problem number 1, section 5.3, back of page 51.
Wait, why would you like consider like 30 minus 15 or something like that?
Because 15 is not a known angle for me. The only known angles are 30, 45, and 60. Now, can I do 60 minus 45? Absolutely.
Is there a difference like the answer you
No,
did?
the answer will be the same. The work will look different, but the answer will be the same. All right? On your reference sheet, you will see a formula that tells you how to deal with the sine of an angle minus an angle. It's right here. The sine of an angle minus an angle. It's u minus v. What does that formula say? If you want to take the sine of an angle minus an angle, this is your u, this is your v. So it'll be sine 45 times
Cosine 30.
cosine 30 minus
Cosine 30. Cosine 45.
cosine 45
Times
sine 30. All right, so take a look at your sheet. That's your identity. You do not have to memorize that. But you have to recognize, first of all, that's the formula you need, because it's a sine problem and I'm subtracting. If you look, there are cosine formulas there too. And there's a sine adding problem or formula. We're doing the sine subtraction. And your u is 45 and your v is 30. Okay? Now, you're going to plug in these numbers. Now, I always think the 45s are easy. Because what do I know about the sine and cosine of 45? They're the same? Am I speaking a language you understand? And what are they? The sine and cosine of 45 are what?
So, obviously, 1 minus. 1 over 2.
1 over root 2
Root 2
or
or
root 2
2
over
2.
2. And they're exactly the same. So the sine and the cosine are both root 2 over 2. Now, 30, see how you are dead meat if you can't do these problems, because you won't be able to fill all these blanks in.
Yeah.
So cosine is root 3 over 2, and sine is a half. No canceling. However, this one would, this is a multiply, so that would be root 6 over 4.
Yeah.
And that one would be root 2 over 4. And since they have a common denominator,
Root 6 minus root 2.
over 4, and that is your answer. Root 6 minus root 4 does not combine.
Not doing anything more with that.
Not doing anything more with that.
That's pretty easy.
It is very easy. It is very easy.
As long, I mean, yeah, we should know how to do that.
Yep, this is,
Try.
remember, that's why chapter 4 is a big deal. You have to know this stuff. Okay. Let's look at the next one. All right, cosine 165. Now, you have to think of two of your special angles that are either gonna add up to 165 or subtract to get 165. There are lots of possibilities. So we'll all get the same answer, but we may think of different options. Anytime one of my number ends in 5, I immediately think of 45. So I'm gonna think of this as 120 plus 45. Now, before you start freaking out, tell me about 120.
60.
It's a 60. So you see, I don't have to use 60. I have to use some angle that gives me 60. So 120 is an option. Do you see that? All right, so what's my formula for cosine? These are added. This is u plus e. Formula says,
Cos 60.
no, I'm using 120.
Oh,
These are my angles. So it's going to be cosine
Cos
120,
plus cosine 40.
not plus, times cosine 45 minus
Close 45.
sine 120 sine 45.
Oh.
Guys, you got to be able to read it off the sheet.
Oh, no.
Okay, so your cosine plus. Doesn't your cosine plus formula say cosine minus sine sine?
Yeah, not far.
Okay, so I got cosine of this, minus sine of this, sine of this. Now I'm gonna fill in my 4 numbers. I love my 45s because why? They're the same. I don't have to worry about getting them mixed up. And what is the cosine and sine of 45?
Root 2.
2 over 2.
Oh.
Cosine and sine of 45 are root 2 over 2. Now, I started to draw my 120 over here, but I never finished it. So this would be root 3, 1 and 2,
1 over
and negative.
Negative 1 half. Yeah. Negative 3 over 3.
So cosine is negative 1/2, and sine is root 3 over 2.
Yeah.
Then you got negative root 2 over 4 minus root 6 over 4.
So negative root 2 minus root 6 over 4. And you might be thinking, wow, that looks a lot like the last one we got. And of course it does, because every time you fill these parentheses, what are you going to be filling them with? Root 2 over 2, 1/2, root 3 over 2. That's all you're going to get. Because you're always doing 30, 60, or 45.
45.
So your answers are going to look like this a lot.
We're only doing, it'll only be 45, 45, and 60. 60,
And 30. Yeah, that's all we can do by hand.
Yeah.
All right, are you with me here? All right, the next one's gonna be a little bit messier. Let's take a look at this one. I can't remember, did I put the tangent identities on? Yeah. Okay, so what's the first thing we have to do? The first thing we have to do is figure out what we can add or subtract to give us 195. Caitlin?
Subtract 150 and 45.
Oh, that's a great idea. I love to use my 45s, and she said we can do 150
So it's 30
plus
degrees.
45. Exactly, Elijah. Some people are out there thinking, wait a minute, how does Caitlin know she can use 150?
Because it's 30.
Because it's a 30. Think about it. A 150 is a 30.
How can I tell which one's my view?
However you set it up, it doesn't matter. It'll make no difference in the 30, however you set it up. So, this is U and this is V, the way I have it written up there. But it doesn't matter one bit. Okay, so I'm gonna go ahead while I got my triangle started and go ahead and finish it. So that would be 1 root 3, 2, and that would be a negative there.
Yeah.
So what's my formula say?
Tan 150
Tan 150
plus tan 45
Yep.
over 1 minus tan 150 tan 45.
Beautiful. Once you figure out what angles you're using, then it's just a matter of popping them into the formula. Okay? Now, we gotta start plugging in numbers. So I need the tangent of 150. So look over here at this picture. The tangent would be 1 over negative root 3 or negative root 3 over 3. So I'm gonna make that negative root 3 over 3. Plus, what about the tangent of 45? 1. The tangent of 45 is just 1, isn't it? Remember, sine and cosine match. And then the same numbers go down here. So 1 minus negative root 3 over 3 times 1. Everybody with me here? Okay, let's clean that up just a tad. So we have negative root 3 over 3 plus 1 over 1 plus root 3 over 3. Nothing cancels. Don't think about it. What would the common denominator be? 3. So I'm going to, keep this however you want, but I'm going to multiply everything by 3. I don't like dealing with all these little fractions, and if I times everything by 3, won't that cancel?
Yeah.
And that cancel? So now I have negative root 3 plus 3 over 3 plus root 3. Does that look all right to everybody? Okay? Nothing cancels because of the pluses and the minuses. The pluses, I guess.
On the
Nothing
top and
cancels.
bottom by 3 minus root 3.
Now we multiply by the conjugate. Because our denominator has a radical, you'll want it. So we have to multiply by 3 minus root 3 on the top and the bottom. And now we're gonna have a FOIL on the top and on the bottom. So very carefully first. Now, what happens when you multiply a root 3 times a root 3?
3.
You just get 3. You know, I told you tangents are more messy than sines and cosines. Ronan?
Do they cancel out the first and last one with the numerator?
No, they're negative.
We're both negative.
See, down here they cancel because you have a negative and a positive, but these are both negative.
Oh, wait,
So I'm gonna have negative 6 root 3 plus 12
Over 6.
over 6.
Can you take a common factor?
Yep, now we got a GCF, so if we pull a 6 out of everything,
Negative root 3 plus 2.
we'll have negative root 3 plus 2, and
That's what the answer.
that's your answer. Now, I know there's a lot, but most of all that was arithmetic. The trig was over here. That's the trigonometry ended here. All the rest of that stuff was just simplifying.
Where'd you get the 1 for the middle part, for the denominator? After the negative root 3? Yeah.
Tangent of 45.
It's 1 over 1. Oh, I see.
All right, cosecant negative 255. I have to erase this. Anybody else have a question about it? Okay, cosecant negative 255. you can look from now until 2 weeks from now, you're not gonna find a cosecant formula on your paper. Anybody have an idea how we're gonna handle this? We're gonna think of it as a sign problem. So, it is. Now, here's what I'm gonna do though. I'm gonna go ahead and I'm gonna pretend for a moment that my problem is this. And I'm gonna work all that out, okay? And I'm gonna get an answer. It's gonna be a fraction. And then I'll simply take that fraction and flip it over. If you start out by saying it's gonna be 1 over, that's fine, that'll work. But then you gotta look at that fraction through the whole problem. So I'd rather go ahead and just get this answer and then flip it. All right? Negative 255. Can you think of 2 angles that are either gonna add or subtract to give you a negative 255?
Negative 210 and negative 45.
Ah, negative 210. Now, do you want to make that plus negative 45 or do you want to make it minus 45? It doesn't make any difference.
Plus.
Plus negative 45. So she's doing it as an add problem. So she's adding 2 negatives to end up with negative 255. Does that work for everyone?
Yes.
Okay, remember what I said at the beginning, there's always more than one combination, so if she picked it, we're going with it, but you may have a different combination, your answer will be the same. All right, so she's doing it as a sine plus, so what's the formula say?
Sine -210 times cos -210 plus cos.
No, cosine negative 45.
Oh, wait. Oh, okay, yes.
Plus,
Sine -45. Cos.
there it is. All right.
Wait, so you're in the third quadrant for Christmas.
So, be careful, negative 210. Negative 210 would actually be up here, wouldn't it? This is negative 180 and this is negative 210. Remember, it's negative 210. So what's my reference angle
30,
here?
30.
30? So I have 1 root 3, 2, and the root 3 is negative.
So
1/2.
So sine will be 1/2. And cosine will be negative root 3 over 2. Is that all right with everyone?
Yes.
And then negative 45 is going to be the same root 2 over 2, except the sign is negative. So cosine is root 2 over 2, and sine is negative root 2 over 2. Now let me stop there and make sure everybody is
Adds up.
keeping up. Now we've done a couple of these already, so would you agree it's gonna be over 4? And it's going to be root 2 plus root 6 over 4, Ronan?
So when we're solving this, we're not solving it in like a cosecant, we're just solving it in sine and flipping
Yeah,
it up.
okay, because, all right, so this is the answer to the question, if it had been a sine. But it wasn't a sine, it was a cosecant. So I'm gonna take this answer and flip it. So my cosecant answer is this. That's my cosecant answer. Flip it. But now, I'm back to where I was a minute ago. I'll have to multiply by root 2 minus root 6. Little hint, don't distribute, you'll see why in a minute. What happens on the bottom when you start foiling? What's root 2 times root 2?
4, 2.
Root 2 times root 2
Two.
is 2.
Two, and then 12.
These are gonna cancel. And what's root 6 times root 6?
Negative 6. No, you're not saying that. No, they can't.
So now we have 4 root 2 minus root 6
So just root 2.
over negative 4. There's a lot of arithmetic, guys. Don't these cancel? So I'm gonna have negative root 2 and positive root 6 because I'm over a negative 1 down here. Wow. You get a root 12 and a negative root 12 when you figure it out. All right, let's look at number 2. This is kind of backwards, okay? So when you look at number 2, forget the numbers. I see sine, cosine, minus sine, cosine. Which formula is that? It has a sine times a cosine minus a sine times a cosine. Forget the numbers and the these and these. Which is it? It's a sine subtraction, right? So number 2a is the sine of u minus v. What's your u? 58. What's your v? 32. So this is the sine of 26?
Yeah.
Done. That's all you have to do. All right, let's look at b. Again, don't put the numbers in yet. Figure out what formula we've got. So for b, we've got tan plus tan over 1 minus tan tan. Tan u plus v. So we have tan u plus v. What's our u? 13. What's our v?
18.
So this is a formula for the tangent of 31. All you're doing is putting the formula back together. All right, C. Cosine, cosine, minus sine, sine. Be careful, what is it? Be careful. Cos u plus v. It's the cosine of u plus v. Guys, look at your formula. Cosine, cosine plus sine, sine
Yeah.
is u minus v.
Yeah.
Cosine, cosine minus sine, sine is u plus v. So what's my u?
12.
X. And my v is?
9x.
9x.
21x.
So this is the cosine of 21x. Now, D ran off the page. That says sine 6, sine 10, minus cosine 6, cosine 10. This one's tricky.
Would it be sine 0 and then
Wait, hold on.
No.
What
There's
do you,
something
secant?
wrong with it.
It's in the wrong format.
It's in the wrong order. So again, I want you to think about what happens when we subtract in the wrong order. If we're doing 7 minus 4, we get 3. What happens if we subtract them in the wrong order? We get a negative. We get the same answer, but it is negative. So whatever this is, it's going to be the negative of what it should be.
Yeah.
So it should be,
Negative
this should
cos
be
minus u.
the cosine of u plus v, shouldn't it?
Oh, yeah, yeah.
If I turned it around, wouldn't it be cosine u plus v? So now I'm gonna have a cosine. What are my two angles?
6, 10.
6 plus 10. So this is negative cosine 16. Does everybody understand where the 16 came from?
Yeah.
and it's negative because the problem is in the wrong order. Now, if this had been a plus, it wouldn't have mattered. But since it's a minus, I'm subtracting in the wrong order. All right, last one.
Negative
Sine 37, cosine 19, plus cosine 37, sine 19. What's that a formula for?
Sine U plus B.
Sine u plus v,
Yes, so negative sine.
and your u and v are 37 and 19, so isn't this the sine of 56?
Mhm. Negative sine, 56?
Oh, no. It's an add. In an add problem, the order doesn't matter,
Oh, okay.
right? Only subtraction doesn't matter. Okay, we've done a lot. So, big day tomorrow,
Why?
because we're gonna have our review quiz tomorrow.
Oh,
All right. I told you I wasn't gonna tell you about how it happened. And we're gonna do a couple more identities, things, and then they take out the finish this.
so we're gonna point this.
5-2 homework, due Wednesday.
What was our last test?
Here we go, we're praying.
Lord, thank you for the food for us, the Irish family and friends beside us, and the love that's left. In Jesus' name, we pray. Bless the Lord.
These, I guess.